Yeah, we're looking at the initial product problem using the method of Laplace transform. Okay, and the equation we have here in this particular question, homogeneous second order differential equation. Okay, and we have the criteria given. This is the criteria given for the differential. Okay, when you are solving differential equation using Laplace transform, there are three key steps to be taken. Okay, to solve differential equation using Laplace transform. Step one, take Laplace. Take Laplace of both sides of the. Step two, find Laplace transform. Step one. Then the final step is short. Find what? Find inverse Laplace what of the expression. So these are the three key steps to be taken when solving differential equation using Laplace transform. So using step one, take the Laplace equation. Okay, and when you are taking it, Laplace of the left hand side, we affect this, this. So minus 2 Laplace of first differential, and then plus 5 Laplace of y, then equal to Laplace of 0, and Laplace of this is this. That's step one. Okay, we said take what? Take Laplace of both sides of the equation. Then step two, Laplace transform. So Laplace transform for second differential is this. That's the Laplace transform for second differential. Minus 2. Laplace transform of first differential is this. We have already explained this one is table 7.2. Then plus 5 Laplace of y. Okay, equal to this. The next thing to do is to substitute the differential criteria you have here. This one, go to your, this one is what? This is 2. And this one is what? This is 4. And this is what? This is 2. But let's begin to factorize the Laplace. Laplace is here. Laplace is here. Laplace is here. Factorize the Laplace. So we have this s squared minus this one times this one minus 2s, then plus 5. So take your Laplace outside. Then we have here 2 times this one, that's a minus 2s. Okay, then here we have what? Minus 4. Then minus 2 times, minus is here, so minus 2 times minus 2, so that's minus 4 also. Okay, equal to 0. Okay, so we can leave this one here and move the other parameters to other side. We now have this equal to 2x. This is a minus 4, that's a minus 8. So when you move to the other side, that's a plus 8. Then make the Laplace the subjects, and that will be equal to this one over x squared minus 2x plus 5. So from here now, we can now take the inverse Laplace of this place and of this place. So the moment you take the inverse Laplace of this, okay, then you have what? We have the function y as a function of t. You have y as a function of t. So you are converting, when you take the inverse Laplace, you are converting from x domain to time domain. Okay, equal to inverse Laplace of this expression. So in getting this inverse Laplace of this fraction, the first thing you have to do here is to check the denominator. Can we factorize the denominator? Is it factorizable? No. Factors of 5 is 1 and 5 and can never generate minus 2. So, and that will call for what we call use of perfect square. And that will be equal to take one of this minus half of 2 is 1, square that. Then what you have here, take it outside and square it plus what? Plus 5. So the perfect square will now become this plus 4. Okay? So what we now do now, we now have this x minus 1 squared plus 4. Okay? So what we'll do here, this letter here, okay, we need to turn it to x minus 1. How do you do that? Let's u equal to this. And then u plus 1 is what? Is this. Okay? So let's substitute that into the equation. So we have inverse Laplace of 2, the bracket u plus 1, and then plus 8 all over. This is what? U squared plus 4. Do expansion, that will be inverse Laplace of this one times this one, that's 2u. 2 times this plus this, that's plus 10, all over u squared plus what? Plus 4. Okay? So the next thing to do now is to return the u back to original function, and that will be 2 into bracket x, this one, x minus 1 plus 10, all over, return this one also back to the original function, plus 4. So we achieve the target of turning this function to this x minus 1. You can see this is it, this is it. Okay, so then after that, you now break this inverse expression into 2 parts, and that will be inverse Laplace of this then plus inverse Laplace of 10 over. So we've broken it into 2 parts now. We have this one, we have this one. So we now have we can move this 2 to outside of the inverse. So we have 2 inverse Laplace of this function all over this, then plus this 10 also, we can move it outside, or we can make it 10 is 2 times 5, 2 times 5, so 5 can be outside and 2 can be inside here. Okay, and why did I do that? I just want to ensure that this 4 here is 2 squared. I have one of it at the numerator, and that's why I split this 10 into 2, 5 times 2, and take the 5 outside. Okay, so the final answer is this. Then you now turn, I've said earlier, that the moment you are using inverse Laplace, you are converting this domain to time domain. So what does that mean? Your answer now will be a function of t now. So this will be what? 2. This is a direct table, and that will be exponential to power t, and then cos all of this cos 2t, and then plus 5 exponential to power t sine 2t. So that's that on this question. Okay, so please check the videos on table 7.1 and 7.2. Okay, check that. I've already explained all this on this one. And again, please, there is an icon on the video. Click on it and subscribe so that you can keep track of the updates of the channel. Okay, why not do it now? Do it now. Okay, make your comments and click on like button. Thank you, and join the next question, question 2 on initial value problem using the method of Laplace transform.